Okay, this is the P3 paper from October 2023. It's question number 4. As you can see, this is an exponentials and logarithms question, in particular, exponential modelling. So let's have a look at the question. It says, a new mobile phone is released for sale. Total sales N are given, N in thousands, yeah, that comes up later, are given by N equals 125 minus AE to the minus 0.109t. This is not an unusual function to have in these sorts of questions, so make sure you've gone through and done lots of practice of these. It says A is a constant and T is time in months after the phone was released. Given that T equals 0 when N equals 32, can we find the value of A? Yeah, absolutely we can. So we had that N, excuse me, was equal to 125 minus AE to the minus 0.109t, and then they told me t equals 0, n equals 32. So it's just a matter of substituting that in. So we get 32 is 125 minus, and then because t is equal to 0, you're going to get a equal to the 0 there, which means 32 is 125 minus a, e to the 0 is 1. So that gives me that A works out to be equal to whatever 125 take away 32 is, 93. Okay, part A done. Let's have a look at part B. So don't forget we've got A now, so that goes into our equation as well. Given that when T equals capital T, the total sales is 100,000, can you find the value of T, giving it to 2 decimal places? So just be careful here. 100,000, but thousands there, so that's actually going to be n being equal to 100, not 100,000. But otherwise, it's just subbing in, so we know at t equals t, n works out to be equal to 100. So 100 is equal to 125 minus a e to the minus 0.109 t, but as I say, we know what a is, so 100 is equal to 125 minus 93 e to the minus 0.109 t. So absolutely standard, not surprised that we're expected to now rearrange this to get t equals. So take 125 off both sides, we're going to get that. Divide both sides by 93, or minus 93, we get that is equal to e to the minus 0.109t. At this stage, log both sides. If this is causing you any problems, you need to go back and do more work on solving these exponential equations. This is a very straightforward process to do, and then t is going to be equal to that, divided by minus 0.19, so log of 25 over 93 works out to be roughly minus 1.3137 divided by minus 0.109, but put the whole numbers in and t works out to be equal to 12.05. Now always just go back and check, obviously I've read it already, decimal places, 2 decimal places, and they might mess around with things like saying 12.05 months and then months into years. Just be careful. There isn't in this question, but just be aware of the fact that they can use the context of the question to sometimes cause problems. Part C, find according to the model the rate of increase. Yeah, okay, so again, the whole point about doing these questions is that that's not throwing me at all. I'm expecting to a differentiation at some stage when we're going through and doing this. So find according to the model the rate of increase in total sales when t equals 7. Give answer to 3 sig figs when we get that far. Look, it's only worth 2 marks because this is absolutely standard that we should be expecting this at some part through doing this one. So we've got that n was 125 minus 93 e to the minus 0.109t, and now rate means differentiating. So differentiating this, again, shouldn't have no problems differentiating this function. Obviously the 125 is going to go, but differentiating an exponential, differential of e to the 2x would be 2e to the 2x. It's basically the differential of that bit multiplied by that. So if we apply that process now to this one, we're going to get minus 93e to the minus 0.109t multiplied by minus 0.109. Okay, well that gives us 10.137 e to the minus 0.109t. And then we know that t is equal to 7, it's in the question. T equals 7, dm by dt works out to be, plugging that in, so 10.137 e to the minus 0.09 times 7 here, and that works out to be 4,000, excuse me, 730, and again, go back 3 significant figures, it says 3 significant figures here. And then part D, so the total sales mobile phone is expected to reach 150,000. Show why this is this equation is not suitable for modelling the total sales of that. Yeah, this is, again, really, really classic last part. So some of my students will put, sorry, go back up there, will put 150,000 in and show that the equation doesn't work, which is okay, but that's not really what they're asking you. They're asking you, what's the limit of the function? So if you can use the right language here, it just means that you'll convince the examiner more that you know what you're talking about. So the way that I would do this is I would say the limit for n as t tends towards infinity, we get 125 minus 93e to the whatever that was, minus 0.109t, but t is equal to infinity. So we get 125 minus 93e to the minus infinity, and we know then that that tends towards 0. So it's 125 minus 0, so it tends towards 125. So the minimum value is 125,000. So if that's true, then the model of trying to make it to 150,000, so 150,000 not suitable. Now, what I would very much suggest you do with all of those part Ds of this style of question is go through and make sure you've checked the mark schemes. The mark schemes are always attached to any video that I do, just to see the language that they use for that part D. Let's just tidy that while I'm talking. Yeah, just to make sure, go and see what they will and won't accept by looking at the mark schemes for those ones. But that could not be any more standard, and you need to make sure you can do all parts of that question. Okay, hopefully that all makes sense to you.